All right, example 5. This is example 5 in the book. Let's do this. If I have the complex number z equals 1 minus 2i, and it's a 0 of this polynomial, it wants me to find the remaining zeros of f of x and write it in its linear factorization. I know that I also have the 0, 1 plus 2i, because those are complex conjugates, which we talked about in an earlier video. So basically, if I use synthetic division with 1 minus 2i and then with 1 plus 2i, I should end up with something I can factor or solve somehow so that I can end up finding my other two zeros. That sounds simple enough. So here we go. 1 minus 2i. Synthetic division. So 4x to the fourth. Then x to the third, I don't have anything. Then 17. Then 14. Then 65. Okay, so this is kind of tricky because we've got a complex number. I've already messed up on it like 2 or 3 times. So let's try this right the first time for you. I drop the 4. Then I multiply, which is just distributing 4 times 1 minus 2i. That'll give me 4 minus 8i. 0 plus 4 minus 8i is 4 minus 8i. Now, when I multiply 1 minus 2i and 4 minus 8i, I have to FOIL that. So, first is 4, outer is negative 8i, inner is negative 8i, last is plus 16i squared. So, the 16i squared is really a negative 16. So 4 minus 16 gives me negative 12. Negative 8i minus 8i is negative 16i. So right here under my 17, I have negative 12 minus 16i. So now I do 17 minus 12 minus 16i, which just subtracts the 12, because that's like terms, so that's going to be 5 minus 16i. Let's FOIL again. 1 minus 2i times 5 minus 16i. I have first, which is 5, outer is negative 16i, inner is negative 10i, last is plus 32i squared. So the plus 32i squared is minus 32. So 5 minus 32 is negative 27. Negative 16i minus 10i is negative 26i. So I'm going to write that up here as negative 26. No, just kidding. Haha, not right. Negative 27 minus 26i. Okay, so 14 minus 27 minus 26i is negative 13 minus 26i. One more time foiling. 1 minus 2i times negative 13 minus 26i. So negative 13 is my first, outer is negative 26i, inner is positive 26i, and last is plus 52i squared. So this becomes minus 52. My middle terms cancel out. Negative 13 minus 15, no, minus 52 is negative 65. So I put that right here, and I get 0, which means that this is indeed a factor. So I'm going to take what I got here, this 4 minus 8i, and the 5 minus 16i, and the negative 13 minus 26i. I'm going to take that, I'm going to do synthetic division with that, and my next 0, which is 1 plus 2i. So I'm going to switch to a new slide that's blank, and then write this out, is that I'm going to put 1 plus 2i into synthetic division with what I had before, which was 4, then 4 minus 8i, then 5 minus 16i, then negative 13 minus 26i. Okay, so synthetic division, drop the 4, distribute, so that's 4 plus 8i. If I add these, I'm adding like terms, which gets rid of the i's and becomes 8. If I distribute that, that's 8 plus 16i. These i's cancel out and I get 13. And then if I distribute that, I get 13 plus 26i, which makes that 0. So 4x squared plus 8x plus 13 is my new, like what I have left of my polynomial, which I can't factor, so I'm going to have to use the quadratic formula to figure out what my last two zeros are. So that's negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. If I simplify that, I get negative 8 plus or minus. Like if I do everything underneath my square root, I end up with negative 144. Well, negative 144, if I take the square root of that, I get 12i. If I simplify this now into, this is basically negative 8 over 8 plus or minus 12 over 8i. So that's negative 1 plus or minus 3/2 I. Okay, so those are my last two zeros. Then I would need to write the prime factorization of that. So the prime factorization, not prime, linear factorization. Prime factorization is totally different. My first two zeros, hey, this isn't example 5 slide. So we'll get to this actual problem here in a second. The first two zeros that I had were 1 minus 2i, so x minus 1 minus 2i. Then I had x minus, and I had 1 plus 2i. Then now I have x minus, and one of them is negative 1 plus 3/2 I. And then x minus negative 1 minus 3/2 I. So that's the prime, not prime, that's the linear factorization for this problem. So that's quite a bit of work for that. So there you have it. Let's do example 6. I have another slide for example 6. So hopefully this will fit on one slide, unlike the last one. If we want to factor this completely, we can look at the graph, which I did not put up, to kind of try to see what a likely candidate would be. Again, we can think about the rational zero test, which would be like the factors of negative 9 over the factors of 3, and see what we get. And those are the possibilities. If I graph that real quick, do I have my graph up? Please let me have my, nope. Well, let's just open up the calculator. Kind of takes it a while to load. There it is. Okay, I want to graph 3x to the 5th plus x to the 4th minus 24x to the 3rd minus 8x squared minus 27x minus 9. Well, it looks like from our graph we have a 0 at -3 and a 0 at +3 and then at some fraction here that I don't know. So we know that we can do -3 and +3. Let's try that. If I divide by -3, synthetic division. So this is like 3x to the 4th minus 8x cubed. There isn't an x squared, that's an x, and that's a number. So now let's do it with +3, because we saw that looked like a 0. So drop the 3, 9, 1, 3, 3, 9, 1, 3, 0. So let's write this out. I have x cubed with the 3 in front, 3x cubed plus x squared plus 3x plus 1. If I want to set that equal to 0, I can factor this by grouping, which I don't know if that's really come up much so far this year. And it's the idea that I can group this into two groups where I factor out what they have in common. Like this first group has x squared in common, so I can factor it out and I'm left with 3x plus 1. And then what I'm trying to do is with the second group, factor out something that gives me 3x plus 1 in parentheses. Well, in this case, I already had 3x plus 1, so I wouldn't factor out anything. So now I can say, all right, I'm taking the 3x plus 1s out. So that's one parentheses, and I'm left with the x squared and the plus 1. So 3x plus 1 equals 0 is going to give me a 0, and x squared plus 1 equals 0 will give me two zeros. 3x plus 1 equals 0 gives me x equals -1/3. X squared plus 1 equals 0. I'd subtract the 1 over and then square root each side, so I get x equals plus and minus. The square root of -1 is just I. So that's my zeros. I have -3, 3, -1/3, and plus and minus I. So the linear factorization of that is x plus 3, x minus 3, x plus I, x minus I, and then this -1/3 is like x plus 1/3, but we can also take that and write that as 3x plus 1, where we just slide the 3 in front of the x, and that means the same thing. And I feel like that would be a little bit better mathematical speak for that. All right, so that's how we do that. This is the end of part 3.